Okay, so next key part that you need to take note of is your different Newton laws. I'll try and keep this segment a bit shorter so that it is bite-sized. First Newton law, it says, every object will remain in its state of rest or uniform motion in a straight line unless the resultant force acts on it. So there's a keyword here, resultant force. What exactly is a resultant force? We'll take a look at this. So resultant force, we covered it in the first chapter already. It is under physical quantities. And for this resultant force over here, what you're trying to do is you're trying to add up the forces. Let's say I got a force acting towards the left, 10 newtons. I got a force acting towards the right, 5 newtons. So if I sum up the forces, the resultant force will be 5 newtons towards the left. And then in this second scenario here, I got 10 newtons towards the left and 8 newtons towards the right. So therefore, my resultant force will be 2 newtons towards the left. And then in this last scenario here, I have force A that is very long, it's on the right hand side, and then I have force B that is shorter on the left hand side. So our resultant force will be A minus B, which is the big force minus the small force. So in this Newton's first law explanation here, it states no resultant force unless a resultant force acts on it, or if there's no resultant force. So what that means is this: when there's no resultant force acting on a stationary object, then what happens is it will remain stationary. And then let's say if you have a resultant force acting on this stationary object, then it will start to move. And then in this second scenario here, it says when there's no resultant force acting on an object that is already moving, then what happens is it will continue at this uniform motion. So let's say I got this object that is already moving at 10 meters per second, and then if there is no resultant force acting on it, then this guy will just keep moving and moving and moving, and so on. We'll try and take a look at this scenario here. So this one, for a stationary object, let's say I got 5 newtons towards the left hand side and then 5 newtons towards the right. So if this object was originally at rest, it will remain at rest. Why will it remain at rest? Because the two forces that is exerted on this block is actually producing a resultant force that is equal to 0. Second scenario here, for object that is already moving. So let's say I got an object that is going towards the right hand side at 10 meters per second. So initial velocity is 10 meters towards the right. And then in this second scenario here, let's say if I got two forces acting on this block, both in both directions, same magnitude also. So what will happen to this object? What speed will it be moving at? Will it be going at 0 meters per second, or will it be going at 10 meters per second? So when you got two forces exerted on this block, what happens is you need to go and think of your resultant force first. And resultant force in this case will be equals to 0 because they cancel each other. So resultant force or net force will be equals to 0 newtons. And we learned under Newton's first law that if there's no resultant force acting on an object that is already moving, then what happens is it will just keep moving in the same direction at the same speed. So as a result, since the object is originally moving at 10 meters per second to the right, what happens is this object will go 10 meters per second towards the right also. So it will be 10 meters per second to the right. That's it. Second law is very straightforward. Your Newton's second law is simply just a formula. It's F equals to ma. So F is your net force. It cannot be any random force, it is only your net force or your resultant force. M is your mass is in kg. And then A is acceleration. Acceleration will be in meters per second squared. So if A is 0, F will be 0. If F is 0, A is 0. This one is just using this formula of F equals to ma. We'll try this third law. This third law is a bit more tedious in terms of conceptual understanding. So Newton's third law over here says when an object A exerts a force on B, B will exert an equal but opposite force on A. So we'll try and understand this law. So let's say if I got my hand and I punch the wall. So why exactly does my hand hurt? My hand hurts because when I punch this wall, I exert a force on the wall. And then what happens as a result of that is that this wall will actually exert an equal force on my hand. So you can go and try and punch the wall. Your hand will be pained because the wall will punch you back. So that's the concept behind this Newton's third law. If I push someone, that someone will push me back. Simple as that. So there are 4 properties that you need to know for your Newton's third law. First one is they are the same force. Second one is they are different in bodies. Third one, opposite in direction. And then last one is same magnitude. Same magnitude means if I exert 10 newtons, then I'll receive back 10 newtons. Opposite direction means I exert forward, then the guy will exert towards me, so backwards. Different bodies means I punch the wall, so I exert on the wall will punch me back. So the 2 different bodies involved will be me as well as the wall. Last one, same type of force. Same type of force just means if I exert force A on this wall, so I exert force A, the wall will exert the same exact force. So it will be force A on my hand. We'll try and take a look at some scenarios here. So the first one is swimming. Let's say you're swimming and then your coach will normally ask you to hold to the wall and then kick the wall. So why is it advantageous for you to kick the wall? So when you kick the wall, what happens is you exert a force towards the right on the wall, and then what happens as a result of that is that the wall will exert a leftward force on you, propelling you forward. This is your Newton's third law. Second scenario is the one that we covered. So when I punch the wall, I exert a force that is on the wall, and then the wall will punch me back. That's why my hand hurts. Third scenario, let's say I got a drone flying. So how does your drone flying even work? So what your propellers does over here is that your propellers will exert a downward force on the air. And then what happens as a result of this downward force is that your air will exert an upward force on the propellers, causing your drone to go upwards. Last one, car exhaust. So for your car exhaust, what happens is your exhaust pipes will exert a backward force on the air, and then your air will exert an equal but opposite forward force on the car, causing the car to go forward. We'll try and take a look at more examples here. So this one, gravitational force, state the reaction force of this gravitational force. First thing we need to understand is what exactly is gravitational force. Gravitational force is your weight. And weight is exerted by Earth. So just imagine this block here, it is being pulled down by Earth, and then what happens as a result is that your block will exert an equal but opposite force on Earth. So just imagine your block is being pulled down by Earth, your Earth is being pulled up by your block. That is your reaction force. And in this case, if we were to go and state it out fully, the full correct answer will be upward gravitational force by the block on Earth. That's it. Last one, this example here is weight and normal reaction force and action reaction pair. So just now we went through the 4 different properties. Same force, different in terms of direction or bodies, opposite in direction, and the last one is same magnitude. So normal reaction force and your weight, they are of the same magnitude, same length. They act on the same body. So normal reaction force is the floor on the block, weight is Earth on the block. So because they act on the same body, it doesn't fulfill the criteria of different bodies. So no, they are acting on the same body, that's one. The opposite in direction criteria is fulfilled because one is upward, then one is downward. But the last criteria that it doesn't fulfill as well is your same type of force. So there are different types of forces here. One is called normal reaction force. The other one is called weight. So besides them acting on the same body, and they are not the same type of force also. Yep. So this will be your explanation. If you're asked to explain why normal reaction force and weight are different, they are not action-reaction pair,